Everything that begins must end, even the universe itself. But what does it mean for everything to end? No more stars, no more light, no more time. Today on Infinity Beyond, we explore the chilling possibilities of how the cosmos may one day die. There are several competing theories, each one more mind-bending than the last, and all depend on the universe's energy content, geometry, and the mysterious force we call dark energy. Let's start with the most accepted scenario, the Big Freeze. As the universe continues expanding at an accelerating rate, galaxies will drift farther and farther apart. Eventually, distant galaxies will vanish beyond our observable horizon, too far for their light to ever reach us. Stars will exhaust their fuel. New star formation will cease. Black holes will be the last to remain, quietly evaporating over trillions of years via Hawking radiation. The universe will go dark, cold, and silent, a state known as heat death, where entropy reaches its maximum and no useful energy remains. In this version, time doesn't end, but meaningful change does. A universe without contrast, without structure, without memory. But what if the expansion doesn't just continue? What if it accelerates uncontrollably? The Big Rip. In this more dramatic scenario, dark energy becomes increasingly powerful, tearing apart galaxy clusters, then individual galaxies, stars, planets, and even atoms. Eventually, space itself is ripped apart. Time ceases to function. Physics as we know it breaks down. We don't know if dark energy behaves this way, but if it does, the Big Rip could arrive in tens of billions of years. Then there's an older, once popular idea, the Big Crunch. If gravity were strong enough to halt expansion, the universe might reverse, collapsing back in on itself. Galaxies would merge, temperatures would soar, and space would shrink until all matter converges into a final singularity. Some versions of this theory suggest a rebirth, a cyclic universe that expands and contracts eternally, perhaps even spawning new realities each time. This leads us to the Big Bounce here. The universe never truly ends. Instead, it oscillates, bouncing between big bangs and big crunches in an infinite loop. Each cycle erases the previous one, creating a cosmic amnesia. And finally, the most exotic possibility: vacuum decay. Quantum theory allows for the idea that we live in a false vacuum, a metastable state that could suddenly collapse into a lower-energy true vacuum. If that happens, a bubble of destruction would expand at the speed of light, rewriting the laws of physics in its wake. Instant, undetectable, inevitable. Maybe tomorrow, maybe in 1 trillion years. At Infinity Beyond, we explore these endings not to frighten, but to marvel. The universe may die, but its story is worth telling. And the more we understand its fate, the better we understand our place within it. Because the end of time isn't just about destruction. It's a reminder to make this moment meaningful.